Good evening, guys. This evening's topic D. Smoking weed and tobacco can shrink key parts of the brain, especially the amygdala, insula pallidum, and overall gray matter. And the science behind this is clear and more sobering than most people realize. Okay, here we go with a narrative that I wrote for you. Smoking weed and tobacco actually shrink your brain. Here are the parts at risk. The human brain is often described as the most complex structure in the known universe, a dense consolidation of billions of neurons, each firing in patterns that shape our memories, our emotions, our decisions, and sense of self. Yet this delicate organ is also vulnerable. What we inhale, ingest, or expose ourselves to can alter its architecture in ways that are subtle at first, but profound over time. Among the substances that exerts measurable structural effects is cannabis and tobacco stand out, not only because they are widely used, but because new research shows they can physically shrink specific regions of the brain. This isn't a metaphor, it's anatomy. The modern landscape of use, cannabis use, is rising worldwide, with more than 228 million people using it annually. Tobacco remains even more widespread, with roughly 1.8 billion users globally. These substances often travel together, mixed in joints, smoked sequentially, or used by the same individuals for different reasons. Their culture presence is un, un, undeniable. Cannabis is framed as natural, uh, medicinal, or relaxing. Tobacco as inhabitable, social, or stress relieving. But beneath these narrative lies a biological reality that doesn't negotiate with public opinion. Both THC, the psychoactive compound in cannabis, and nicotine, the stimulant in tobacco, act on receptors deeply embedded in the brain's communication networks. THC binds to CB1 receptors, influencing mood, appetite, and pain. Nicotine binds to nicotinic acetylcholine receptors, altering learning, reward, and attention. Over time, repeated activation of these systems doesn't just change how the brain functions, it changes its physical structure. The brain regions that shrink, the amygdala, emotional regulation, and threat detection. Multiple studies show that regular cannabis users have a smaller amygdala. This almond-shaped structure governs fear responses, emotional learning, and the fight or flight system. Shrinkage here can subtly alter how a person interprets threats, manages stress, or processes emotional memories. Tobacco users also show reduced amygdala volume, suggesting that both substances converge on this critical emotional hub. 2. The insula, self-awareness and internal states. Tobacco use is strongly linked to smaller insula volume. The insula helps you sense your heartbeat, hunger, pain, and internal emotional states. It is also deeply involved in addiction, especially cravings. Shrinkage here may reinforce dependence, creating a feedback loop where the brain becomes structurally more vulnerable to the very substance causing the damage. The palladium, motivation and movement. The palladium part of the basal ganglia shows reduced volume in tobacco users. This region helps regulate movement and motivation. Structural changes here may contribute to slower cognitive motor processing, reduced drive, or altered reward pathways. The total gray matter, the brain's processing power. Perhaps the most concerning finding, Tobacco users experience a faster decline in total gray matter volume compared to non-users. Gray matter is where thinking happens, memory formation, decision making, emotional regulation, and sensory processing. Losing gray matter is losing cognitive capacity. Cannabis research shows smaller effects on global gray matter, but the amygdala shrinkage is consistent across multiple studies. Why shrinkage happens? The brain is plastic, consistently reshaping itself based on experience, but chronic exposure to psychoactive substances can push its plasticity toward structural loss rather than growth. TH, THC overstimulates CB1 receptors, altering synaptic pruning and emotional circuitry. Nicotine overstimulates acetylcholine receptors, changing neural communication and metabolic demands. Both substances, both substances influence inflammation, blood flow, and neural connectivity, which can accelerate tissue loss over time. The result is the result is not dramatic, like a stroke or injury. It is gradual, quiet, and cumulative, a slow erosion of volume that becomes visible only through imaging or cognitive decline. The human impact, what shrinkage means in real life. Brain shrinkage doesn't announce itself. Instead, it shows up as subtle emotional dysregulation, increased anxiety or irritability, difficulty interpreting social cues, reduced motivation, slower cognitive processing, greater vulnerability to addiction, lower resilience to stress. And adolescents at high risk for psychosis. Cannabis tobacco co-use is linked to worse cognitive performance across multiple domains. This suggests that structural changes may translate into functional impairments, especially in vulnerable populations. A larger story about brain health. The narrative here isn't moralistic, it's biological. The brain is an organ that responds to chemical exposure. Cannabis and tobacco, despite their cultural differences, both carry measurable risk to brain structure. The shrinkage is not uniform, and the effects vary by dose, frequency, age, and genetics. But the pattern is clear. These substances alter the architecture of the brain in ways that matter. Understanding this doesn't require fear, it requires honesty. The more we know about how these substances shape the brain, the better equipped we are to make informed choices, support public health, and protect cognitive well being across the lifespan. Copilot provides personalized suggestions based on your open tabs and delivers better answers by using context clues like your current page. Okay. Guys, here's the second part of D. Study links cannabis and tobacco co-use to lower brain performance in at-risk adolescents. Adolescence is a threshold, a time when the brain is still sculpting itself, pruning connections, strengthening others, and laying down the cognitive foundations that will carry a person into adulthood. It is also a time when vulnerability and possibly coexist. For young people at clinical high risk for psychosis, this developmental window is even more delicate. Their brains are already working harder to maintain cognitive stability, emotional regulation, and social functioning. Into this fragile landscape enters a growing trend, the co-use of cannabis and tobacco. A study published in the biological psychiatry, cognitive neuroscience, and neuroimaging brings this issue into sharp focus. It fills a critical gap in our understanding of how these substances interact with the developing brain, not in the general population, but specifically in adolescents who are already navigating The early warning signs of psychosis. The findings are not abstract, they speak directly to families, clinicians, educators, and the communities who are trying to protect young people during one of the most consequential periods of their lives. A rising pattern with real consequences. Cannabis and tobacco co-use has been rising for decades among U.S. young adults age 18 to 25. 1 in 5 daily cigarette smokers is also a daily cannabis user. In the general population, this risk for mental health disorders. But until now, no study had examined how co-use affects neurologic, neurological activity, performance in adolescents at clinical high risk for. Psychosis. The very group for whom cognitive changes are often the earliest sign that something is shifting beneath the surface. The research team analyzed data from 734 at risk adolescents and 278 healthy control controls drawing from the North American Prodome longitudinal study. 2 studies of psychosis risk participants reported their substance use over the past month and completed a comprehensive battery of neuropsychological tests. The results were clear. Adolescents at high risk for psychosis who used both cannabis and tobacco performed worse. Across a broad range of cognitive tests compared to healthy controls. This wasn't limited to one domain. It was widespread, affecting memory, processing speed, executive functioning, and other cognitive systems essential for daily life. A surprising twist. The non-users subtype. One of the most unexpected findings was that at-risk adolescents who reported no substance use at all also showed lower cognitive performance and the lowest social functioning. This challenges the synaptic narrative that no use equals no risk. Instead, it suggests that some adolescents may be so socially withdrawn that they simply have fewer opportunities to engage in substance use. Their lack of use may reflect isolation rather than protection. Researchers proposed that these non using adolescents may represent a distinct socially impaired subtype within the high risk population. This insight matters for families and clinicians. Social withdrawal is not neutral. It can be an early sign of emerging illness, and it can mask risk factors that might otherwise be visible. Why this study matters. Psychosis does not appear overnight. It unfolds gradually, often beginning with subtle cognitive changes, difficulty concentrating, slower processing, trouble with memory, or challenges interrupting social cues. These early shifts can precede more recognizable symptoms by months or years. This study highlights that cannabis and tobacco co-use may exacerbate these early cognitive vulnerabilities. It also underscores a broader truth. Substance use during adolescence is not just a behavioral issue, it is a neurodevelopmental one. For youth already at risk, the stakes are even higher. The human story behind the data. Give me 1 second, folks. Gotta get this part. Behind every data point is a younger person trying to navigate adolescence while carrying an invisible burden. Some may use cannabis or tobacco to cope with anxiety, stress, or social pressure. Others may be experimenting, seeking belonging, or simply following the norms of their peer group. But for adolescents at clinical high risk for psychosis, these substances may interact with their developing brains in ways that deepen cognitive challenges and complicate early intervention efforts. The study's authors emphasize that causality remains unknown. We cannot yet say whether co-use causes cognitive decline or whether cognitive vulnerability increases the likelihood of co-use, but the association is strong enough to warrant attention, especially as co-use becomes more common. Implications for families, clinicians, and communities. The findings offer several practical takeaways. Clinicians should routinely ask about cannabis and tobacco co-use, not just one or the other. Families should understand that co-use is not benign, especially for adolescents already showing early signs of psychosis risk. Educators and caregivers should recognize social withdrawal as a potential risk factor, not simply a personality trait. Early intervention programs should integrate substance use screening into their assessments and support plans. This study does not demonize cannabis or tobacco. Instead, it calls for action for understanding how these substances interact with vulnerable brains during a clinical developmental window. A call to continued research and compassion. The authors stress the need for future studies that track substance use and cognitive performance over time. Okay, guys, that is your D for the night. I will see everybody tomorrow evening for shows. Until then, Gator Wellness, take care, folks.